All right, Dr. Matthew J. Traum here. I'm going to solve a mechanics of materials problem for you. We're asked to draw the shear and bending moment diagrams for the beam with the loading shown, and then we're asked to determine the maximum absolute value for the shear, and then for the bending moment. Once we draw the diagrams, we'll be able to pluck those absolute maximum values right off. So our goal is to draw those two diagrams. We've got this beam. We don't know what the reaction forces are at A and C, so we got to find those first. I'm just going to guess that they're both in the positive Y direction. I don't know that, but I'm going to get to the answer and see if my guess was right. And I'm going to notice that positive moments are counterclockwise, following our convention. The easiest way to get to those reaction forces is to just take the sum of the moments around C and then around A. You end up with a unique solution for RA, which is -6 kips, and then a unique solution for RC, which is 54 kips. And then I can use those values in my shear diagram, which is here. So I'm going to have a point A here, I'm going to have a point C here, and I'm going to have a point B here. And I'm just going to construct this thing visually. So I know my boundary condition for RA is -6 kips. And I know that I've got a continuous load going downwards. And so what I'm looking for, I don't know what the value is at C, but the slope is going to be basically a linear constant negative. And when I get to C, I'm going to have this reaction force RC. It's going to jump up, and I don't have any load from C to B, so I'm going to have a constant value. And then I've got my 30 kips pointing down, which gets me back to 0 at point B. So that's the shape of the diagram. And now I've got to figure out some values. So remember, I had to go down to get myself back to 0 at point B. So I know that this is 30 kips. And because there's no load from C to B, I also know that this is 30 kips. And so I've got most of the key points figured out. I've just got to figure out what this guy is. And the way that I get to that guy is to remind myself that VC minus VA is equal to the area from XA to XC, which is under this diagram, which is a load of 3 kips. Of course, negative because it's pointing downwards, and then distributed over 6 feet. So what I end up with there is -18. And I started at -6. So if I say VC is equal to -18 minus 6, I get a value of -24. And so that's my value here is -24. So now I've got all my values for the shear diagram. First thing I'm going to do, since I've got this, is I'm going to say, what's the maximum value, absolute value of the shear diagram? Well, I've got 2 candidate points. It's either 30 or 24. 30 is bigger than 24. So for A, I'm going to say that max value is B equal to 30 kips. We got that sorted out. And now that I've got my shear diagram, I can draw my bending moment diagram. So I'm going to do the same thing, looking at the shear diagram to work out what the bending moment diagram looks like. And again, I've got my point A, I got my point C, and I've got my point B. And I'm noticing that this guy is a constant slope negative value. And so what I'm looking for, I should mention, I have the beam starts at A and it ends at B. And so I have no moment at A and I have no moment at B. So those two values have to be 0. And as this line slopes downwards and negative, I know that the shape has to be concave downwards, right? Because that slope is ever decreasing. It's ever increasing in magnitude, decreasing that it's getting more negative. So this is going to look like a curve like that. And then here I have a constant positive load. And so this is going to just be a straight line shooting back up like that. So this is that point that I need, because nowhere else am I going to have any bending moment that's greater. So what is that value? Well, the easiest way to get to that value is to just remember area here under the shear diagram is the value in the moment diagram. So MB minus MC is equal to this area, which is 30 kips. And 3 is the distance, so that gives me 90, and that's the value here. So this is going to be minus 90, and that's the answer to B, right? Is maximum bending moment. I'm just taking the absolute value. This is a negative. But all I care about is the absolute value. So I'm going to say maximum moment is M is equal to 90. And that's going to be cubic feet, right? Cubic feet. Okay, so those are my answers. Thanks for your attention.